In this video, we're going to talk about completing the square, which is a simple but very useful technique for putting quadratic expressions into a convenient form. Let's begin by taking a look at a particular quadratic expression and trying to factor it. If we apply known techniques and try to factor this as a product of two linear expressions, recall that we need to find two numbers whose product is equal to 4, that is the constant term in the quadratic expression, and whose sum is also equal to 4. That's the coefficient of x. And of course, what's true here is that those numbers are 2 and 2. In other words, this particular quadratic expression factors as a perfect square, x plus 2 squared. And that's just about the nicest way that you can hope for a quadratic expression to factor. Now let's imagine that we take that original quadratic expression and change it just a little bit by changing the constant term from 4 to 1. Question: can we still factor this quadratic expression as a perfect square? Well, the answer is unfortunately no, but there is something we can do that comes kind of close. Namely, we can take this quadratic expression and do something a little sneaky. We can say that since we know that x squared plus 4x plus 4 factors as a perfect square, what we can do is simply add a 4 and subtract a 4 from this expression. This means, of course, that we don't change its value at all. Now, since the portion of the quadratic expression that I'm putting in parentheses does factor as a perfect square, we can simply factor it as such. This will be x plus 2 squared, and then add a constant term, negative 4 plus 1, or negative 3, to the result. And this new expression that we've arrived at is what's known as completing the square. We have just completed the square for the original quadratic expression. So completing the square is just a technique that allows us to take a given quadratic expression and, even if it doesn't factor as a perfect square, express it as a perfect square plus a constant. That's the whole idea. It simply remains to devise a general method for doing this, and that's not too hard to do by thinking backwards. So what we're going to do here is begin with a perfect square, x plus a squared, where a is just some arbitrary constant, and FOIL it out and see what we get. What we get, of course, is x squared plus 2ax plus a squared. This immediately shows us the special properties that a quadratic expression which does factor as a perfect square must have. Namely, its constant term must be exactly 1/2 of the coefficient of x squared, right? Because a squared is just 1/2 of 2a squared. That means that if we start with a general quadratic expression of the form x squared plus bx plus c, we can complete the square by adding and subtracting exactly 1/2 of the coefficient of x squared. So what we'll do is rewrite the expression, in this case, as x squared plus bx plus, and now I want to add b over 2 squared, and I also want to subtract b over 2 squared, so that I don't change the value of the expression. And finally, I shouldn't forget about the constant c. And it will now be the case that everything I'm putting in parentheses will factor as a perfect square. And it will factor, to be precise, as x plus b over 2 squared. And then, of course, there's a constant term that's left over, and that constant term is going to be b over 2 squared plus c. So we've now here completed the square in very general terms, And once again, all we had to do was add and subtract 1/2 of the coefficient of x squared. Let's finish up by looking at a slightly more advanced example. The goal here is to complete the square for this particular quadratic expression, and what separates this quadratic expressions from the ones we considered previously is that there is now a coefficient of x squared that is not equal to 1, right? This is a coefficient of 4 in front of the x squared. Well, the way to proceed, however, is really very straightforward. All we're going to do is begin by factoring out that 4. So I'm going to factor out a 4, and then obtain 4 times x squared minus 2x plus 3. And now we can simply complete the square for the quadratic polynomial that's inside the parentheses. What we want to do, as usual, is look at the coefficient of x. That's minus 2, and I'll make a little side calculation here. We're going to take the minus 2 and divide it by 2 and square the result. Right, and that's just equal to 1, of course. And what this means is that in order to complete the square, we're going to want to add and subtract a 1. So here's how it's going to play out. So this is going to equal 4 times x squared minus 2x. Now I'm going to add and subtract a 1, like this. Now everything I'm putting in parentheses does indeed factor as a perfect square. In fact, it factors as exactly x minus 1 squared, just like this. And then we're going to add to that the minus 1 plus 3, that's just 2. And finally, so as to put our answer in the most convenient form, I'm going to distribute that 4 that we factored out at the beginning. So this will become 4 times x minus 1 squared plus 8. And that's it. We've completed the exercise, and we have completed the square. And this last example really shows how you can also complete the square for a quadratic expression if the coefficient of x squared is not equal to 1, if it's equal to some other number.